young math Padawans, it's Mrs. Angel with your lesson for today on segment addition versus segment inequalities. In this lesson, we'll be given a diagram that is drawn to scale, and we just have to make conclusions based on what we're given. So make sure you have these notes, and let's get started. Here we have our first diagram, segment JL, and K is between J and L. Let's take a closer look at specifically what we are given. We are given that the length of JK is 5 units. We are not given the length of KL, but we are given that the length of JL is 17 units. So in other words, we are given a part of the segment. We are asked to find the second part of the segment, but we are also given the whole segment. So as we recall from our segment addition lesson, the conclusion that we can make here is that part plus part equals the whole thing. So now we can fill in what we know. We know that the first part, JK, is 5 units. We know that the second part, KL, is our unknown. So you could either represent it with X or a question mark, but I'm just going to leave it as KL so that I know what I'm talking about. And we know that our whole is 17 units. So you could look at this equation and solve by subtracting 5 on both sides, or we could just do some mental math. 5 plus what is 17? 5 plus 12 is 17. So we know without a doubt that the length of KL has to be 12 units. So bringing this back to my diagram, I now know that this is 12, and then I can ask myself, does it make sense? Well, does 5 plus 12 equal 17? Yeah, 5 plus 12 does equal 17, so this diagram now makes sense. That's when we're given all of this information. Let's look at the same diagram, but this time we're going to take something away. In this example, it looks like we're given the same diagram, and kind of we are. However, something's missing. We're still given segment JL, and K is still between. We're still given that the length of JK is 5. And we're still given that the length of KL is unknown. But what's missing here? We're not given the length of JL. So we kind of have to forget the last example. We don't know what JL is here. It could be anything. It could be 10. It could be 25. It could be 100. We don't know. So normally we would just be stuck here. There's nothing we can do. However, we're being asked to just make a conclusion, not necessarily find the answer. So I'm going to lead you through what's called creating a segment inequality. So the goal here is not to find the actual length of KL. It's just to make a conclusion about that length, and specifically how it compares to the length of JK. Now, the most important statement on this problem is the fact that this diagram is drawn to scale. That means that whatever appears to be true in this diagram, we can use that in our conclusion. So looking at this diagram, my goal is to somehow compare the length of KL to the length of JK. I notice that KL is longer, clearly longer than segment JK. But that's just comparing the segment. I want to make a more specific comparison about the segment length. So if segment KL is longer, that means the length of KL has to be greater than the length of JK, right? Longer, greater, that makes sense. My length KL, whatever that is, has to be greater than my length JK. Well, we don't know the length KL, but we do know the length of JK, and that's 5. So because this diagram is drawn to scale, I know that from K to L has to be greater than 5 units. So what could that possibly be? Well, KL could be 6 units. KL could be 10 units. KL could be 5.5 units. It could be anything as long as it's longer than 5. So if you're not given the whole, you can at least make a comparison of the two lengths. Here's our third example. Again, we're given this diagram is drawn to scale. The length of RS is 2x minus 5. The length of ST is 9. And the length of RT is 3x. So really, the only part that we know here is 9. I would say our conclusion should be to try to find the actual length of RS and the actual length of RT. But to do that, we need to set up an equation and solve. Well, we're given 2 parts and we're given the whole, so why don't you solve this one using segment addition? Part plus part equals whole. Let me quickly take you through how I did this. Now again, the goal wasn't to just find x though, the goal was to find the length of RS and the length of RT. If RS is 2x minus 5 and x is 4, then I can just plug in x equals 4. 2 times 4 minus 5, that would be 8 minus 5 and 3. So the length of RS here is 3. The length of RT is 3x. So plugging in 4, 3 times 4 gives us a length of 12. Now, does that make sense? Does 3 plus 9 give you 12? Absolutely it does, which means we've now made as many conclusions as possible on this diagram. Now, what if we were given this diagram? Again, we have segment RT. We're given that the part RS is 2x minus 5. We're given that the part ST is 9. But again, something is missing here. We are not given the whole length of RT. So this is not the same problem as the last one. Now, at least we're given the fact that this diagram is drawn to scale. That can allow us to set up an inequality. We can compare the length of RS to the length of ST based on what we see in the diagram. Okay, how would you compare segment RS to segment ST in this diagram? I would say, looking at this diagram, that segment RS is clearly shorter than segment ST. So that means that the length of RS is less than the length of ST. And that can allow us to make some type of conclusion about X. So if RS is less than ST, we can fill in what else we're given. We're given that RS is 2x minus 5, and we're given that ST is 9. So let's solve for X the same way that we would solve an equation. X is less than 7. Now, what does that actually mean? Not much, unless we're able to make some type of conclusion, bringing it back to the diagram. So let me show you how we can check this. We're really concerned with the length of RS here, because we don't know anything about RT, and ST is already given. So to check that X is less than 7 actually makes sense, we're going to pick a number less than 7, and we're going to plug it into RS to see if it makes sense. So what if we picked 6? 6 is less than 7. Let's plug it in and see if it makes sense. 2 times 6 minus 5. That would be 12 minus 5. Okay, 7. So if X is 6, that means RS is 7. Would that make sense given in the diagram? Well, yeah. Is 7 less than 9? Absolutely. So that could be one possible value of X. We could also check something like 3. 2 times 3 is 6. 6 minus 5 is 1. That would also make sense in the context of this diagram. Just for comparison's sake, let's try one that we know wouldn't work. Let's try a value greater than 7, like 8. If we tried 8, that would be 2 times 8 minus 5. 16 minus 5, that would be 11. Let's put it in our diagram. Would it make sense that the length of RS is 11? Not if this diagram is drawn to scale, which we know that it is, because that would mean that RS is longer than ST. So the only conclusion that we can really make here, since we're not given the whole length, is that the value of X has to be less than 7. As long as it's less than 7, it should make sense in this diagram. So just to quickly recap this video, if we're given both parts and the whole, we can use segment addition to make conclusion about the diagram. But if we're not given the whole thing, we can use something called segment inequalities, and at least we can make some type of conclusion about our missing measure. That's it for today's lesson. I will see you next time.